Okay. Yeah. Some students asked me about if I can talk a little bit more about the analysis of data. Okay. So yeah, let's just start from the data analysis. The first one is compute GM theoretical and GM experimental. Okay. So the GM theoretical just the equation. Okay. Let me see. Yeah, this one. Okay. Using this equation. Actually, from the equation 2.2 and 2.3, 2.4, 2.5 is just the expansion of the equation 2.2. So from the theory, it can be shown the metacentric high GM is. So this one, 2.2, is the theoretical GM. Okay. So by using this equation, you can get the GM theoretical in 3 cases. Okay, the only difference, uh, the differences for 3 cases, you can find the equation 2.4, EB equals to H over 2. Okay, so the H, which is the draft are different because for the first one you're using the empty vessel, but for the second and the third one, for the second case you're adding 2 kilogram, and for case 3 you're adding 4 kilogram. So the draft will be different too, right? So for different draft, the EB is different, and also for the EG is from the bottom of the vessel to the center of gravity is also different. Using the equation 2.5, you can get. So WP is the vessel weight, the vessel weight, and XP is given. XP is 125. Okay, so 125 is the let me see, is the center of gravity of the empty vessel. But let's see. Okay, draw a line. If you add some weight in here, okay, so the center of gravity will be somewhere in here. Okay, so basically the center of gravity of the added ballast weight to the bottom of the vessel is the XBI. Okay, so if you're adding 4 kilogram, which is two iron blocks, piled up together, so the center of gravity, the added weight in K3 is kind of, the center of gravity is going up. So I would say the XB2 in case 3 is larger, and that's the reason why it's different for the case 2 and case 3. Okay, so as you can see in here, XB1 is 30 millimeter and XB2 is 37.2 millimeter. So that's the difference. So for case 2, you just plug 30 in here. Okay, WBI is 2 kilogram times G. Okay, so you're able to calculate the center of gravity in each case. So that's very important. The drafts are different, and the center of gravity to the bottom of the vessel, the distances are different too. So just make sure you know that. So you're able to calculate the GM's theoretical using the equation 2.6. And GM experimental, well, that's equation 2.10. Okay, and for each case, GM theoretical is just one number. one value, but the GM experiment are different because I provide you guys a list of data with different listing angle. Every listing angle, there is a corresponding mass. Okay, so basically for one mass, you can calculate one FP. Okay, yeah, FP equals to the mass times G. Okay, that's your force. Okay, on the side of the vessel. In RA, I think I already mentioned RA in this equation. So that's GM. GM experimental is just a list of numbers, and you just tabulate them. Okay, you make a table, say, oh, this is a case 1, and there's a list of the GM experimental, and you will use for graph. Later, plot the tilting angle versus the added weight for 3 ballast load condition. Okay, let me draw a picture to show you what does this looks like. Okay, so versus the added weight. Okay, let's use tilting angle theta as the y-axis, and using the added weight. Okay, m, the mass. Okay, so basically, I would see it could be something linear. Okay, it could be something linear, and you can extrapolate. It would be a line like that, because the more weight you're putting on the side of the vessel, the listing angle is getting bigger too. Okay, so it's something like that. Okay, I'm not sure if it looks like that, but if it looks like that, eventually it could be a curve or something. It depends, but the general trend is the bigger the mass is, the bigger the listing angle is. Okay, it could be a curve like this or a curve like this. I'm not pretty sure, so you need to find out what does it looks like. Okay, for the part 3, make 3 plots EM experimental view versus tilting angle. Okay, yeah, this one is very important. Okay, so the plot will become, the x-axis is the tilting angle, and this is your GM. Okay, this is your GM experimental as the y-axis, and you also will have a list of lots of point. It's a scatter plot. You're just doing like a scatter plot. I mean, just for example, I mean, the actual GM experimental will not look like that. But what it asks you to do, fit a straight line to each of the experimental data sets and extrapolate the lines back to an angle of 0 to find GM experiment 0. What does it mean is in the Excel, you have the ability to draw a trend line using linear interpolation, and you will find a trend line, and you're able to ask Excel to provide you the equation. Okay, usually like that, x y equals to ax plus b. Okay, and actually the b in here is the intercept. Okay, if your line intercept with y-axis, sorry, if your line has an intercept with y-axis, the intercept will be the b value in here. And the b value in here is actually the GM experimental 0 we're looking for. So once you have the equation, you just get the b, okay, using this b as your GM experimental 0. So for each case, you have one GM experimental 0. So later you can have a table. That's the content of the part 4. Okay. So basically, what I want is to make a table like that. This is a case 1. This is a case 2. And this is a case 3. Okay. And you have your GM theoretical. You have your GM experimental 0. Okay, it's gonna be 6 numbers, and the GM theoretical should be pretty close to GM experimental 0. Okay, let's see if the number is 1.2. It could be 1.3, and this one could be 2 and 2.2, and for the third case it could be 2.5. And GM experimental 0 could be 2.8 or something. I mean, if there's no big mistake or error in the data, these two numbers for each particular case should be pretty close. Okay. So as long as these 6 numbers are correct, I think that's the right way. I mean, you're in the right way. You don't really have to check the procedure or something. But if these numbers are far away from each other, probably you have to check your solution pretty carefully. I mean, in each equation, you're doing something wrong. Like EG value, if you're getting it correct, or let me see, the common problem could be the EG value. That's one thing I'm thinking of. And or in the unit conversion or something else could cause you to have the difference in the GM theoretical and GM experimental. And let me repeat what I want in analysis of the data. Okay, so tabulate this. Okay, using a table to tabulate the GM theoretical. Actually, just tabulate the GM experimental will be fine for each case. And GM theoretical, you can just leave it to the part 4, because you eventually you have to make a table for GM theoretical and GM experimental 0. So just leave this part to part 4 and just tabulate the GM experimental. Okay, that's one table. And plot tilting angle versus added weight for 3 ballast loading condition. Okay, so that's 3 plots. Okay, we have 3 plots for part 2. Okay, make 3 plots, GM experimental versus tilting angle. That's another 3 plots. So 6 plots in total, and 2 tables for part 1 and part 4. So 2 tables, 6 figures. That's what I want. Okay, I think that's pretty much it. Don't forget to do the discussion point. Just use your own words, whatever you want to express. Okay, I think that's pretty much it.